Welcome to today's lesson on forces. If you have ever pushed something and noticed it starts moving, you have encountered the power of forces. But not all forces are equal. In today's video, we are going to dive into the concept of unbalanced forces and how they make objects move. Let's start with the basics. Forces are pushed or pulled on an object, okay? So basically, if we pull the box and if we push the box, both actions are exerting a force on the box. When forces act on an object, they can either balance each other out or they can cause the object to move. It's all about balance. Okay, now let's see that. We're drawing a box in here. Okay. And then I'm exerting a force in this direction, let it be 50 Newton, and another force in this direction, let it be also 50 Newton. And we can see that both of the forces are balanced and equal to each other, opposite and equal to each other, right? So they will cancel each other out. As we can use vectors in here, we are taking the right side positive and the left side negative. So this will be minus 50. And if I have to find the resultant force, I will just add them up. 50 plus minus 50. That gives us 0. So this means there is no resultant force acting on this box. So the box stays still because both of the forces are cancelling each other out. This is where unbalanced forces come in. So, when the forces acting on the object aren't equal, the object starts to accelerate. Acceleration means it's moving, right? What does acceleration mean? It means it's moving. So let me just change this force to 70 Newton. Now we have a greater force in here, right, than this one. So they are not equal to each other. They are still opposite but not equal to each other. So if I have to find the resultant force, I will again add them up, 70 plus minus 15. That gives us 20 Newton, right? So now we have a 20 Newton resultant to the right. So now this box will move to the right with 20 Newton force, right? As there's a resultant or unbalanced force acting on it. Another name for a resultant force is unbalanced force. Now let's move into this example. In real life, unbalanced forces are everywhere. Think about a car accelerating. So we know that if a car accelerates, there has to be a resultant force acting on it. Without resultant force, there will be no acceleration. Okay, let's just write it in here. Without resultant force, there will be no acceleration, right? There will be no acceleration. Now, the car is moving with acceleration, with an unbalanced force. So there has to be a stronger force acting on this car, right? So can you identify the two forces? Actually, there are 4, but we will just consider 2 forces for now that's working on the car. One is the force from the engine and another is the friction from the tires, right? So this is the frictional force. And this will be the force from the engine. So let it be Fe, okay? So there are 2 forces acting on this car. And as this car is accelerating, there has to be a resultant force acting on this. So how do you find the resultant force? So the resultant force will be Fe minus Fr, right? So when it's accelerating, we will subtract the smaller force from the larger force, okay? So the resultant force will be distant. If we add some values in here, 20 Newton and this is 5 Newton, this will be 20 minus 5. That gives us 15 Newton. Okay, so unbalanced forces explain a lot of world around us. Okay. For example, if we roll a ball from a slope, like this ball is rolling down, right? Because of its weight. And there has to be a frictional force acting on this. Okay, so we can see that this force is greater, thus why this ball falls down to down the slope. Okay. Now if we talk about a rocket, let's say this is a rocket. Okay. And this rocket also moves forward because the engine gives us a thrust force upwards, and there has to be a air resistance pulling opposing the motion of the rocket. So there has a resultant force of what? Upthrust from this rocket engine and a downward force from the air resistance, right? That's why the resultant force will be upthrust from rocket minus the air resistance. So this is the larger force and this is the smaller force. Now, unbalanced forces can also work in opposite directions. Okay. If the force that is moving on an object is reduced or countered by a stronger force that is opposing the other force, the object will slow down and eventually stop. For example, let's take a ball, okay, and let's say that this ball is going in this direction with a 20 Newton force, and its friction is acting opposite of this force, that is, let's say, 50 Newton. Okay, so now the resultant force is to the left, right? And we consider left as negative and consider right as positive for our bigger understanding. So now, if we sum up the resultant force will be 20 plus minus 50, right? And the resultant force will be minus 30 Newton, right? So this minus indicates that the resultant force is to the left and the motion of the ball is to the right. So initially the ball was moving to the right with a velocity of, let's say, 5 meters per second. So the motion is to the right, but the resultant force is acting against the motion of this ball, right? So whenever a resultant force acts against the motion of an object, it decelerates or eventually comes at rest. If we think of it like that, the ball is moving in this direction and the resultant force is acting in this direction. Let's say the ball is moving with 5 meters per second and the resultant force is minus 30 Newton. So the ball will eventually comes at rest as this velocity will decrease because of the negative resultant force. And a negative resultant force or unbalanced force indicates a deceleration or a negative acceleration. Okay. Deceleration or a negative acceleration. So we knew that the acceleration is the car is moving with increasing velocity per second, right? So the car is moving with an unbalanced force. And as the unbalanced force is acting against the motion in the opposite direction, the acceleration will be negatives and the car will eventually come to rest as the velocity decreases per second. I hope this clears up. So if we summarize this up, this will be an object moves when an unbalanced force is acting on it. Unbalanced force or resultant force. So whenever there is resultant force, there has to be an acceleration. Okay. And when there's an acceleration, the velocity of the object increases per second. And now, if the resultant force is acting opposite of the motion, the resultant force will be negatives. Right? So does the acceleration. If we consider right positive and left negative. Now, as the acceleration is negative, the object will eventually comes to rest as the resultant force is acting opposite of the motion. velocity will decrease and eventually comes to rest. So thanks for watching. I hope you understood it, and if there's any problem, comment down below, I will let you know.